Hi class. In this video, I'm going to go over how to set up a NAT router for our network. But before I do, in my boredom, I came across a story that people are doing something called the Corona Challenge. They're going around and licking things in public to for TikTok videos. Some moron licked a toilet seat and is now in the hospital. You have people posting TikToks licking things in public. I cannot stress this enough. Please don't do this. It's amazing what people are coming up with to keep themselves entertained. But I thought that was an interesting thing I read today. Okay, guys, I'm signed into Ace IT Labs. I've connected to my lab and I started router A. We're only going to be working on router A today, so I didn't boot up the other two machines. I'm going to pull up something else we're going to need. And another thing I'd like to point out is in D2L, if you scroll down to final exam, I've updated the map. This is the only one you're going to see. I filled out the chart of all the subnetting that we did a couple videos ago. And I also filled out our map with all the IPs that I'm using on each interface. This IP is from the range of subnet 0. These two IPs are from the range of subnet 1. One on this router, one on this router. These two IPs are from the range of subnet 2, and there's a subnet address. One for this router, one for this router. And this IP is from this subnet, subnet 3. So what we're going to do is we're going to turn this router into a NAT router, and what it will do is all the IPs in these networks are private IPs, and we're going to send them out this router to get to the internet. As the packet traverses this router is going to edit all the packets. It's going to pull out the private IP address and port number and replace it with a public IP address and port number, then enter it in something called a NAT table. And I'm going to show you that NAT table probably in some few other videos. And it only does that on the first packet. So if there's of the communication. If there's multiple packets, it only does it on the first packet. And from that point on, it just replaces all future packets going to the same destination with the same public IP and the same port number. So it only examines the first packet, edits it, put an entry in the NAT table. All of the packets that follow, it'll just pull that entry out of the NAT table, replace the private IP and port number with the public IP and port number, and send that packet back. When the packet comes back, it sends that packet out. When the packet comes back, it looks in the NAT table and does the reverse. It pulls out the public IP and public port number and replaces it with a private IP and a private port number and sends it off to each device. Now, I also posted a LinkedIn learning video describing how NAT works. And one thing that the video didn't go into is the RFC 1918 article. And basically what this article does, and was approved by the Internet Engineering Task Force, IETF, Internet Engineering Task Force. This is the committee that decides what is acceptable in the internet. And this RFC is where they define 3 private address ranges. Anything starting with a 10, anything starting with 172.16 through 172.31, and anything starting with 192.168. So basically, if you're using any of these IP addresses in your private network, they will not be routable on the internet. We talked about this in earlier classes. So if a router on the internet sees one of these IPs, it just drops it. It doesn't even forward it. So you need a special device that will translate those private IPs into a public IP. I'm trying to find it where. Yeah, this article isn't describing it, but basically you need a NAT router or a proxy server to have these computers access the internet. Most people don't use a proxy server. Most people use a NAT router. So these IP addresses are free to use in your private network. When they go out to the internet, the NAT router will translate them from a private IP to a public IP, send it out. When it comes back, it does the reverse. Takes that, removes the public IP, puts back in the private IP, and sends it to the destination. So I'm going to connect to my router. I've already configured all the IP addresses in the previous video, and now I'm going to install the routing software. So I'm going to click on Manage, Add Roles and Features, and keep going down until I get to Server Roles. Look at this. It's saying I can't do anything because I need to do a reboot. I guess an update was applied. So if I try to go on, I'll try to continue to see if it'll allow me. Click Next. Excuse me, sorry, let me just tell you what I clicked. I clicked on Remote Access. That's our routing software. Click Next. Go all the way down to Role Services. Then choose Routing. And add the tools to manage routing. It also selects Direct Access and VPN. You'll learn about that in a later class. But for right now, we're just looking at the routing stuff. Click Next. 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 I'm going to click Restart if needed. In this case, I think it is needed. I'm going to click Install. I'm going to pause the video while it's installing the software. Okay, my router is booting automatically because of the Windows update, so I'm just going to let it boot. Okay, class, it finally updated and rebooted, so now I'm going to sign back in. I'm going to pause the video again till it settles down. Now it's finishing up the update. Okay, the installation is done, so I'm going to close this window, close the notification. I'm going to click on Tools, Routing and Remote Access. Just like all these utilities, first thing you do is highlight your server, right click, configure and enable routing and remote access. Sorry, I went too fast. On the first screen, let me do that again. Configure and enable routing and remote access. Then we're going to go into network address translation. It's going to use one public address to allow all your internal clients to get to the network. So I'm going to click Next. If this screen is blank, press Cancel and redo it. And the second time through, it'll show up. About 50% of the time, this screen will be blank. So if you get that, just press Cancel, go back through the wizard. So now it's asking which interface is connected to the internet. And we're going to say public. Then it's asking us which interface do we want to share our internet access with. Well, we want to do it with both subnets, but this wizard only allows me to add one. So I'm going to choose one, say subnet 0. And then when I get inside, I'm going to press Finish. I'm going to add the second one. Give it a minute to finish the configuration. I'm going to pause it while it does this. This is taking longer than normal. Okay, it's done. So now I'm going to expand our router, expand IPv4, then highlight NAT. Now if NAT doesn't show up here, because there's a glitch, you need to come to the Server Manager, go to Manage, remove roles and features, and remove that remote access. Let it reboot, then add it again. It's a glitch, so you just have to uninstall it, reinstall it. Okay, so now we're back to our routing remote access. So right now we have one public interface. It's public and that is enabled. This one is for the router itself. It's a private interface. And this subnet 0 is a private interface. But the wizard didn't allow us to add both subnets, only subnet 0. So I'm going to right click that and add a new interface. If you have internal here and not here, you're going to do this twice, once for subnet 1 and once for internal. But for me, internal showed up properly where it belongs. So I'm going to add subnet 1 and make it a private interface. So basically what's going to happen is anything on internal subnet 1 or subnet 0 is going to be translated out to public interface when the packet traverses this router. So our NAT is fully configured. If I right click NAT, sorry, if I right click public, I can look at our NAT table. So these are all the packets that have gone out so far. Hold on 1 second. So I can see these private addresses were translated. We're pretending that this is a public IP address given to us from our ISP. In this case, our ISP is the school. So we're assuming that this is a real public IP address. It's not, but that's what we're going to pretend. So it took this IP address of 172.16.16.1 with a port address of 53,473 and translated that to our public IP at 61.240. So this is what was the private IP address and the private port number coming from this machine. But on the internet, it's known as 10.0.0.12 with this port number, 61,240. So basically when that packet comes back to this machine at port 61.240, this NAT router will know to translate it back to this when it sends the packet onto their private machine. So that's how the NAT router keeps track of which port went where, which packet went where, is based on these port numbers. This is the address it was being sent to. These were the public IP addresses the packets were sent to. This is where they were from. The NAT router translated the from address to this address and port number and sent it to this address. This is where it's really from, but this is what the computers on the internet see when they get that packet. So I'm going to close this out. That's it for this video, and I will be setting up the routers on router B and router C in the next video. We're actually going to install the routing software on router B and router C. Thank you.